Hello guys, welcome to this brand new video. In this video, we are going to be building a full stack application using LangGraph in the backend. We are going to be using FastAPI. We are going to be using React in the front end, and we are going to achieve something that is very similar to what Perplexity does in the UI. So I'm not sure if you've used Perplexity before, but it basically, it's basically like a very smarter version of Google. You can think of it like that, right? So if I were to ask some question that requires the AI agent powering Perplexity to actually make an internet search, the user, I can actually look at what is happening on the UI. So, I can see something like, it's searching the web right now. It is actually reading through all these URLs. It is actually giving a response as well. So I would be able to see all these different things. So that is exactly what we are going to be building as well. In addition to that, all these, it's going to remember our previous conversations, all these different words as and when the tokens are being generated, it is going to be streamed to the front end, so the user is not going to wait for anything. So let me actually quickly demo it for you. So let's test out the first thing. Okay, so there's a few errors right here, we don't have to worry about it, but let's just say hi, my name is Harish, right? So in this case, it's basically just going to, you can see that every single word is actually being streamed and it is shown in real time. So it says, hi Harish, how are you? How can I assist you today? In this case, I can ask like, what was my name again? So it should be able to tell, okay, your name is Harish, because it remembers the previous conversations. So this is a very small part. Now let's actually ask the agent something that is a little more tricky. The agent now has to actually make a Google search, an internet search, only then it can actually respond to it. So let's ask something like, when is the next SpaceX launch? Okay, so right here, it is actually going to, search the web. So you can see it's searching the web. This is the query. And then it is actually reading from all these different URLs, all these different pages. And then finally, it is saying that the next SpaceX launch is scheduled for Sunday, April 6th. So this is going to be a very exciting full stack application. So in the backend, in LangGraph, we are going to be learning how exactly to build this graph. It's going to be very simple. We are going to be learning check pointers for memory, for persistence. We are going to learn how to actually set up streaming. And if for some reason you're not a front-end developer, you don't want to, you're not interested in learning about React, etc., that is absolutely fine. You can just go ahead, steal my code, copy paste it, and it would just start working out of the box. So I'm pretty excited about this application. So first thing, let us now go ahead and start building out our agent graph. So let's now go ahead and build out our LangGraph agent graph. So once we build out our graph, we can then wrap our graph using an API endpoint, and then we can connect it with our front end, right? So you can see that I've already gone ahead, created a folder called Perplexity 2.0. I've created two folders, client and server. So right now the client and the server is empty. So let's now first go ahead and build out our server side code. So I'm going to open it using my Visual Studio Code. So let me just zoom in a little bit. So the first thing that I'm going to do is I'm going to install virtual environment. And we need the virtual environment because we want all our packages that we are going to be installing later on to be isolated in this one particular location. We don't want it to be available globally. So to initialize my virtual environment, I'm going to say Python 3. I'm saying Python 3 here because I'm working with a Mac right now. If you're working with a Windows, in that case, you can just say Python. And then I'm going to say -m. This stands for module. I'm using the venv module, and the folder that I want created right here, I want it to be named as venv as well. So right here, in a while, you can see that we have the venv folder created. All right. So the next thing is we have to activate this virtual environment. So right here, you can see that the path is not really pointed to venv, it is still pointed to base. So in order to activate this, since I'm working with a Mac again, I'm going to say source. Okay, I'm going to go inside of the venv, and then I'm going to go inside of this bin, and then I'm going to invoke this activate file. Okay, so this is going to activate my virtual environment, as you can see right here. In Windows, it's a slightly different command. You can look it up. Okay, it's pretty simple. All right, so now that we have the virtual environment initialized and activated as well, now I'm going to go ahead and I am going to create an app.jupyter notebook. Okay, and now there's a couple of packages that we might have to install in order to build out our graph. So I'm going to go ahead and install. First thing is I'm going to install LangGraph. We absolutely need LangGraph. And then I'm going to be using LangChain OpenAI chat model. Okay, we can always use other chat models. We can use Gemini, we can use Grok to access Llama models. But in this case, I'm going to be using the LangChain OpenAI chat model. And then we need the LangChain core package, and then we also need python.env because we want to make the environment variables available inside of our Jupyter notebook, right? And then we also need FastAPI, and then we also might need LangChain community, because in the LangChain community we can actually get access to a lot of tools like the Tavily search tool, etc., etc. So if at all we need something else in the future, we can always come back here and then we can install it. So let's go ahead and install it. All right, great. So now that it has been installed, let's go ahead and import a few things. And guys, before we start coding this, I expect you to know LangGraph already. Okay, so I expect you to know LangGraph, LangChain, the fundamentals of it. I expect you to know how to build a React agent. I expect you to know the basics of streaming. I expect you to know, how persistence works, etc., etc. If you do not know any of these fundamentals, I have created a course that I'll attach the link in the description below. That course is going to take you from absolute beginners to, pro level. We are going to be covering, what are the different types of agents, how to build a React agent, how to do streaming, how to do persistence, how to, what are checkpointers, how to do human in the loop, how to build complex architectures like, the supervisor agent. So I would have covered everything. So I would expect you to know it already. If you do not know it, please go ahead, watch that, and then come back to this video. All right. So now let's actually go ahead and start importing our, modules. So the first thing is we are going to need from typing. Okay. So from this, we are going to need the type dict and the annotated and the optional. So basically, why do we need these things? We need these things because we want to define the state of our agent graph, right? And then we are obviously going to need LangGraph, and inside of the graph module, we are going to need the add messages method. This is going to be the reducer method, which is going to let us easily update the graph state. And then obviously we are going to need the state graph and then the end node. Okay, so what's the next thing? And the next thing is we are going to need a chat model. Basically, chat models are tools that LangChain gives us, which lets us interact, basically like interfaces, which lets us interact with LLMs, right? So in this case, I'm going to be using OpenAI's chat model. But if you don't want to pay for it, you can always go for Google's chat model, or you can go for Llama's chat model. All right. So just go to Google, search for chat model Google. In that case, it's going to give you a different chat model. You can import it and use it. But in this case, I'm going to be using the LangChain OpenAI, and I'm going to be using the chat OpenAI chat model. All right. And then obviously we are going to need the .env as well, because we want to load all our environment variables in this file. And then we are going to need the Tavily search tool. The Tavily search tool is what is going to let our agent access the internet. So in this case, we can actually go to LangChain community, and then we can say tools. And inside of this, I can, access the Tavily search. So I can say Tavily search results. So the last thing that I want is the ability to persist our graph. So what I mean by that is we need memory introduced. So I'm going to be using a check pointer. That is the go-to way of introducing persistence in our graph. Okay, because we want our application to remember what the user said previously, right? So in this case, I'm going to be using LangGraph.checkpoint.memory. Okay, so from this, I'm going to be using the memory saver. And then after this, we also would need the UUID, because we will have to create unique IDs for each user session. So in this case, we might need the UUID. Let's use UUID 4. All right. So we are done with most of our imports for now. So now I'm going to go ahead and I'm going to create an env file. And right here, we need to add a couple of, environment variables for, the Tavily search. Okay. So for the Tavily search results, we might need the API. For the chat OpenAI as well, we might need the API key. So for the OpenAI API key, I'm going to go to platform.openai.com. I can go inside of the profile, and I can go inside of API keys right here. And now I can go ahead and create a secret API key. So I can just say perplexity, and I can go ahead, I can have the permission set to all, and I can go ahead and copy this. And the same thing for Tavily search as well. So I can just go to this particular link, log in, and then I can just go ahead. You can see that I've already created a few Tably, API keys. I can just copy this thing, come to the env file. So what would be the environment variable name? So if I go inside of the chat OpenAI, you can see that it requires this particular environment variable set. Okay, so just put the API key that you would have copied there inside of single quotes or double quotes right here. And then the same thing you will have to do it for the Tably search as well. So if you come inside of here, you can see that this is the environment variable. Okay, environment variable key. Alright guys, so I've already populated all the environment variables in my file. So in this case, I'm going to go ahead and load all the environment variables. And the first thing that I'm going to do is I'm just going to make a simple LLM call and make sure that everything is working fine. So in this case, I can just say this is going to be the model. So I can say the model that I want to use is going to be GPT-4o. And now let's go ahead and invoke this model. And we can say something like, give me a joke about cats, let's say. Okay, so let's get the response right here. Then let's also, okay, so let's try to run this. So you can see that running cells with this virtual environment requires the IPyKernel package. So let's go ahead and install that as well. All right, so now you can see that it is running and it should give us a joke about cats. All right, perfect. You can see that we are getting an AI message back. We are saying that why was the cat sitting on the computer? So everything is working fine. If at all you're getting an error saying that, insufficient balance or something like that, just go ahead and top it up. You can go to the billing and you can top it up. It's going to last you anywhere from 3 to 6 months. I paid it several months ago and you can see that it's still, I've still got a lot of balance. All right, perfect. So now let's get rid of this. And now let's also actually go ahead and test out our Tably search. Okay, so I'm going to initialize our Tably search. So in this case, I can say search tool. Okay, so search tool, Tably search results. And in this case, I can just set the max results to 4 in this case. Okay, so now I can just go say search tool. Okay, what's happening? Search. Okay, so I can just say search tool dot invoke. Okay, I can say what is the weather in let's say what's the weather in Bangalore. So in this case, this is also going to give us a proper response. Okay, so I'm just going to test out all the environment variables, make sure that everything is working fine. All right, perfect. So now you can see that we are getting an array of 4 different objects. Each of these objects are going to have title, okay, and the URL and the content. Okay, you can see that there's quite a lot of content. Basically, this Tably search is very similar to a Google search. Okay, it searches for this particular query. This is the URL that it pulled all this particular content from. So this is the query and this is the URL that it pulled all the content from, right? Okay, so we've got a lot of different information, which then later the agent can actually use. Okay, so the agent can actually make use of this particular tool whenever it needs to, needs that particular data, live data, and then it can actually make some informed decision. All right, perfect. So now that this is also working fine, I'm just going to clear this out again. And then we can just say tools. And right now we're just going to have this one search tool in the list of tools. All right. So what's the next thing? So next thing is we can actually go ahead and initialize our memory saver as well. Okay. So this is going to be the check pointer that is going to introduce persistence in our chat application. Now let's actually go ahead and create an LLM instance that is going to have access to these tools. So I can just say LLM with tools. Okay. So I can just say model dot bind tools, and then I can pass in all these list of tools right here. Okay, so what this is going to, let me actually put it in a separate code block. Okay, so what this is going to do is, now if I were to actually LLM with tools, now if I ask a question right here that is actually going to require some live data, okay, that is going to require live data, in that case the LLM is not going to give an immediate answer, but instead it is actually going to call the search tool. Okay, so if I were to ask something like, what is the current weather in Bangalore? Okay, so in this case, it is going to, let's see what it actually returns. Okay, tools is not defined, and that is because we have not run this. All right. So in this case, you can see that the AI message does not have any content, but instead, if I go to the tool calls, okay, so where is the tool calls? Let me actually search for it. Tool calls. All right. So in this tool calls, you can see that in this array, there is going to be one tool call. So the LLM actually wants to call the Tavily search results JSON because we've provided it. We've bound all the tools right here. Okay. So it actually wants to call this particular tool, and this is going to be the query that the LLM is suggesting as well. Okay. So now we have the LLM with tools instance as well. Okay. Which is perfect. Okay. So what's the next thing? So now let's go ahead and build our graph. Okay, so let me copy paste some code right here. All right, guys, I've copy pasted a bit of code right here. So before I actually walk you through this particular graph, so I'll show you what is the structure of the graph that we have built. Okay, so if you've actually followed along with my LangGraph course, okay, this is something that we would have done a million times already. So you can see that we have the start node at the very start, and then we have the model. Okay, so the model, anytime the user question is something that requires the model to make a tool call, in this case, the control flow is going to go to the tool node. Okay, so in the tool node, this particular tool node is going to make use of the Tavily search, and then it's going to, take the query that the LLM has provided. It's going to make the internet search, and then it's going to return the response back to the LLM. Okay, and if the internet search is sufficient, in that case, the LLM is going to, end this particular graph. Okay, so this is what we have built right here. So if I scroll up here, you can see that we have, this is going to be the initial state. So to achieve this particular thing, we just need the messages list, and we are going to be using this particular add messages reducer function. So if you do not know how this reducer function works, if you do not know the different types in which we can update the state, all of these things I would have covered in the course. So do check it out. All right. So initially we have the first node, which is going to be the model node. Okay, so if I come back to the diagram, you can see that that is going to be the entry node right here, right? So we have this particular entry node. So this node is going to get the entire state right here, and we are going to be using the LLM with tools. We are going to invoke, and we are going to pass in the entire list of messages, and then we are going to update the state with it. All right. So also another thing that I want you to note here is that we are going to be using the async await keywords. And why do we need to do that? Because when we are dealing with production applications, and when there's going to be a lot of concurrent users, in that case, you don't want to block the thread. Okay, so we want multiple threads to be working concurrently. So in that case, we will have to use async await, and we will also have to use the a-invoke method and not the plain invoke method. Okay, the functionality is going to be very similar. All that we're doing is we're going to be using a-invoke and adding async and await in all our nodes. Wherever there is an async operation, wherever there is an LLM call that is being made, or an API call is being made, we have to do async await there. So right after this particular model is executed, we are actually going to look at this AI message right here. Okay, so that is what this tool router is going to do. Okay, so it is basically just going to take the latest AI message, okay, and then it's going to look at the tool calls. Does it have any tool calls or not? If it has some tool calls, in that case, it is going to route the flow of the graph to the tool node. Okay, so or else it's just going to go to end. So let's come inside of the tool node. Okay, so this is going to be the custom tool node that handles tool calls from the LLM. Again, we are going to take the, the last AI message. Okay, so this is going to take the last AI message, and then we are going to go inside of the tool calls. And from that tool call, we are going to get the name of the tool call. In that case, it's going to be the Tavily search results JSON, because that is the only tool that we've made, that we've provided to the LLM. We can also get the args. So in this args, this is where the query, the internet search query is going to be located. So we are going to get a reference for that as well. And then we also need the tool call ID. And then we are going to execute the search tool with the provided arguments. So we are going to provide all the queries and all the, everything that is inside of the args. And then this is going to give us the search results. So we are just going to stringify it, and then we are going to add the tool node in the tool message and the tool name as well. Okay, so now we have the final tool message that we are going to append to the list of tool messages, and then we are going to update the node as well. So this is going to be the function, the tool node function definition. There is also another pre-built, tool node class that LangGraph provides, because this is such a common thing, right? Okay, whenever we are working with agents, calling this particular code block is going to be such a common thing. So LangGraph actually wrote a class and then just gave it to you for us to use. So if I actually go back to, this is part of the LangGraph series that I'd worked on. So here you can see that in a lot of different sections, we would not have actually written this entire thing. We would have just used this tool node right here. Okay, so this LangGraph pre-built import tool node, and I would have just like instantiated this tool node, passed in the tools, and this would have been the tool node. Okay, so exactly what we've done right here. Okay, so we can either do this or that, but I'm doing it this way because this gives you a lot more, transparency on what is happening inside. But if I actually go inside of this particular tool node, you can see that this is basically what we're doing right here. Okay, so we're taking the latest AI message, we're going inside of the tool calls, and then we are invoking it, and that is it. Okay, so that is exactly what we are doing right here as well. Perfect. So coming down, we are going to be using state graph. We are building the graph. So the first node is going to be the model node. Okay, so that's going to be the entry point. And then we also have the tool node, and then we are adding a conditional edge. So right after the model is executed, we have to look at whether we have to go here or here. So that is why we have this tools router right here. Okay, so the tools router is going to decide if this tool calls is present, at least one item is present or not. If something is present, in that case, we have to go to the tool node, or else we have to go to the end. Okay, so I hope this makes sense. And finally, during the compilation step, we are going to provide the memory, the check pointer right here. So that is it. So now let's actually go ahead. Let me run this as well. And let's now go ahead and put this to test. So I can say graph.invoke. Okay, so in this case, in the messages array, I can use this human message. Okay, so I can ask something like, how are you doing? Okay, so let's just test it out. Response. Okay, so we are getting an issue right here. Okay, so this is because we are using the check pointer right here, right? So in this case, since we are using a check pointer always requires a session ID. Okay, so the graph needs to know which session is it storing the particular state for, right? So in this case, we have to actually go ahead and create the config object. Okay, so let's say config. Inside of this, we have to say configurable. Okay, in this we have to say thread ID, and right here we can say 1 or 2 or 3, and then we can provide this config right here like this. Okay, so now everything should work fine. Okay, so it's still not working, and that is because, okay, so to fix this, we just need to say a invoke, and then we have to await this as well. And now let's also, go ahead and change it to, let's say 5 or something. And now let's say, let's introduce ourselves, and then let's ask what my name is, so that we can also test out the check pointer. So hi, I'm Harish. Okay. So in this case, okay, so you can see that we have the first human message, and then the AI message is saying, hello Harish, how can I assist you today? So let's actually test out the persistence, if it is working or not. So I can say, what is my name? So now you can see that all the past conversations are being carried forward, right? So we have the first thing that I sent, and now it is actually, remembering that my name is Harish. Okay, so now let's also try to ask a question that requires the agent to make an internet search. So in this case, I can say, when is the next SpaceX launch? Okay, so in this case, it would actually have to go, utilize the Tably search tool, and it would have to fetch internet results, right? So you can see that right after this particular question, you can see the AI message, the content is empty. In this case, it is actually, suggesting to call a tool, right? So in the tool calls, you can see that it is saying that, use this particular tool and pass this particular query inside of this particular tool as well. Okay. And then finally, what happens is we have tool message, right? So this is going to be the return, the response from the Tably search. This is going to have all the information. You can see it has pulled information from nextspaceflight.com. It pulled it from, a lot of different URLs, right? See, it pulled from spacelaunchschedule.com as well, right? And then finally, the last AI message is going to have the next SpaceX launch is scheduled for this particular date. Okay, so everything is working fine. And finally, I also want to show you how streaming works, because this is not what we want, right? We actually want every single token as and when it is being generated to be streamed to the front end, right? So what I mean by that is, so whenever I ask a question here, let's say what is the current weather in Chennai itself. If you remember, every single word was like streamed to the front end, right? It wasn't like, abruptly there. So this is going to give you abruptly. This is not what we're interested in. We want data to be streamed. So let's also get a quick rough, idea about how streaming works as well. And then we can all put it together later on. Okay. So I'm going to create another block. So in this case, I'm going to be saying graph. In this time I'm not going to be using this a invoke or invoke. That is going to abruptly give you the final response. That is not what we want. In this case, LangGraph provides another method called a stream events. Okay, so this is what we are going to be using. So let me actually show you how this works. So in this case also we can use an input. Okay, so where is the input? Okay, so we can actually copy the same input. So let's put it here. So in this case, I'm just going to introduce myself here. Hi, I'm Harish. All right. Okay, so what's the next thing? So similar to what we do right here, we are providing the config, right? We have to do the same thing here as well. Okay, so I can give it a different thread ID this time. I can say 6 this time. All right, and now what's going to happen is this is going to return us a generator function. Okay, this is going to give us something like, we can say events. Okay, so anytime there is an event getting emitted, we can actually loop through this iterable and then print it. Okay, so I can say for event in events, and then I can print this particular event. Okay, so I hope that makes sense. So this is going to be an iterable. Anytime there is an event getting emitted, this function is going to run. All right, this particular block is going to run. So now if I run it, I hope that everything is looking good. Okay, we have not provided the config right here. Okay, so we have not provided the config. And one more thing that I've forgotten is we also have to provide this version. Okay, by default, it's going to be v2, but still let's also go ahead and provide the version as well. Okay, so there is version 1, okay, and there is version 2. There's a lot more information being emitted in version 2, and that is what we are interested in. So let's actually go ahead and run this and make sure that everything is looking good. I'm not sure if we actually have to await it here as well. Okay, I'm not sure if we have to do it here or here. Let me actually run it. Okay, so we're getting the error. So in this case, it is saying that we have to actually use the async await. Okay, so right here, we are not using that, right? So I can do something like this. So I have just put the async for event right here. So we're using async to iterate over the async generator. All right. So now you notice that if I were to now run this, you should be able to see a lot of different events that are being generated. So you know that this is the question that I'm asking, or rather I'm just saying I'm Harish. In this case, you can see that a lot of these events are being generated right here, right? So you can see there's a lot of events. So you can see that we have on-chain start. Okay, so we have on-chain, on chat model start, on chat model stream. Okay, so all of these are event. Okay, so this is a particular event item. This is another particular event item, right? So in one particular event object, we would have the event type. We would have data. Right, we would have another property called metadata as well. These are some things that I would have deep dived in the LangGraph course, but I'll just give you a quick overview as well. So I'm not able to search for it. Metadata. Okay, so you can see that we have metadata here. That is going to give you information about which node this particular event was emitted from. Okay, so we have all these different information through which we can actually isolate these events, and then we can yield it to the front end, right? So I can actually do something like this. So I can say, if event is equal to on chat model stream, because we're only interested in this particular event type. Okay, I can just isolate that particular thing alone, and I can go inside of the data. So inside of the data, I can go inside of the chunk, and then I can just extract the content alone. So if I clear this file and if I change it to, let's say 7, and if I run this, it's pretty fast. So give me 100-word, essay on climate change, let's say. Okay, change. So you should be able to see the words that are getting populated. Okay, so you can see that every single word was getting, streamed. Okay, so this is what we're interested in, guys. All right, so next up, we are going to transfer all these files. Okay, so when we are dealing with production applications, we are not going to be working with Python notebooks, right? So we are going to be creating a plain Python file. We are going to be, importing FastAPI. We are going to create an endpoint around this agent so that the front end can start accessing it. Okay, so that is what we're going to be looking at next. Hello guys. So in the last part, we built out our agent graph, but we built it out using the Python notebook. So basically what I have done right now is that I've created a new file called app.py. I basically transferred all of these code, okay, to a separate, Python file. Okay, so no difference at all. I have imported the same exact imports. Okay, so you can see that I'm initializing the memory, initializing the state. Okay, so we have the model node, we have the tools router, and then we have the tool node as well. And then I'm connecting all these different things together. So up until here, we've completely already seen. Okay, so coming down, this is the new code that I have added. Okay, so it's going to be very simple. All that I'm doing is I'm importing FastAPI, okay, from FastAPI. I've installed that as well. Okay, so coming down, you can see that I've initialized the FastAPI app. I'm adding some middlewares. Okay, so this is basically just to, for our browser, for our client to be able to communicate with the server endpoint without any issues, without any cost issues. I've added these things. All right, so here, look at this thing. So we have the chat stream. This is going to be our endpoint. So whatever new message that the user in the front end is going to enter, that information is going to come right here. Okay, so that is what we are accepting in this particular argument. And the second argument is going to be the checkpoint ID. Okay, so this checkpoint ID, this is going to be provided as a query parameter. Okay, so if at all the client does not provide a checkpoint ID, that is completely fine. In that case, we are going to default to none. Okay, so we are going to default to none. But if they do provide something, in that case, we are going to accept it. And okay, so let's pay attention to what we are doing right here. Okay, so if it was a simple, if you're not thinking about streaming or anything like that, we can just go ahead and we can just say graph invoke or a invoke. In this case, we can just provide the message inside of this, and then we can use this particular checkpoint ID as well. It's going to be very simple, but since we are interested in streaming right now, okay, so in FastAPI, we are going to be making use of this concept called server sent events. Okay, so it's going to be server sent events. Okay, server sent events. This is for your own education. You can definitely Google it, research more about it, learn more about it. But essentially, server sent events is slightly different from WebSockets. Okay, so what is the difference between server sent events and WebSockets? WebSockets essentially, establish a consistent connection between the server and the client, and both the client can communicate the server as well as the server can communicate with the client, right? It is bidirectional. But in our application, in our project, that is going to be an overkill. What we need in our chat application is going to be server sent events. So what this means is that the server can actually communicate with the client. Okay, so it's going to be one directional, not bidirectional. This is what we need. So the way that we can do this in FastAPI is that we can use this streaming response class that FastAPI provides. Okay, so streaming response. So the first thing that we have to provide in here is going to be the generator function. So the generator function is just going to, emit events. Anytime it receives something, it's just going to emit it. And then the second thing, this is very, very important. Okay, so in the media type, we have to set it to text event stream. Okay, so this is going to be the protocol that we are going to be using, the server sent event protocol. All right, so let's actually take a look at this generator function. Let me now expand this thing. All right, so first off, we are going to check if the checkpoint ID is there or not. So if it is a new conversation, we have one if block right here. If it is an existing conversation, we have another else block right here. So let's look at the first block. Okay, so the first thing is we are going to generate the checkpoint ID, and then we are going to construct the config object. And then we are going to be using the same aStream events method that we just looked at, in the IPy notebook, right? So we are going to be using the aStream events. We are going to provide the message that is received. We are going to use the same thread ID. Okay, and then this is how we are going to be yielding. Okay, so this is what this is a generator function is going to emit the events, or we can also say it's going to yield events. So if we put yield right here, okay, this is what we are going to be sending back to the client. So we are going to be looking at exactly how the data looks like using a Swagger docs. Okay, FastAPI provides a very easy way for us to actually look at exactly what is being emitted from the API. So we'll take a look at that. So here you can see that we are the type is going to be checkpoint, and we are going to be providing the checkpoint ID. So you might think that why are we using all these // It's basically just to escape this particular double quotes. Okay, so we can't use double quotes within double quotes without escaping it like this. Okay, so that is why we are yielding it like this. And if you're wondering why we are saying data right here and why we are saying /n/n right here, so we have to say that because that is basically just how the server sent event protocol works. This is how the browser is going to know that this is going to be a server sent event. Okay, so we just need to follow this. All right, so now we've seen this particular if block. Let's now move on and let's understand the else block. So let's say this is going to be a continuing conversation. In that case, we are going to be using the checkpoint ID that we get from right here. Okay, so we are getting it from right here. So the server knows exactly which session to continue the conversation. Okay, and then the same thing is again continuing. Okay, the same thing. And coming down right here, you can see that we are getting reference to the event type, and then based on that we are doing a couple of things. Okay, so for every single different event type, we are structuring it in a certain way and then sending it to the client so that the client can differentiate between each event type. Right? So the first event type that we are interested in is the on chat model stream. This is going to be a very basic, this is going to be the most common thing that we are streaming. So what I mean by that is, let's come back to our Jupyter notebook. So if you remember, okay, so let me say, okay, I've just said that give me a 100-word essay on climate change. In this case, you can see that this is going to be, the events that are going to be emitted when the LLM is actually generating something, right? So this is when the LLM is starting to generate, and this is when it has started generating already. So that is why we see, the empty array, empty string, climate change refers to significant long-term changes in global or region. So this is what I am going to be grabbing next. Okay, so how can I grab it? So you can see that I'm passing the event data chunk inside of this particular method. It's just going to be a fallback method. Let me show you what it means, but I'm going into event data and chunk. So this is going to be the entire event. I'm going to go into data. I'm going to go into chunk. Okay, so I'm grabbing this AI message chunk. I'm passing that inside of this method. All this method is going to do is it's just going to check if this chunk is an instance of AI message chunk. Okay, so there might be some situations where there could be something going wrong. In that case, I'm just going to show an error. Okay, so that is all that this is doing. So we're grabbing this content. So this particular content, I'm grabbing that particular content, and then I'm just going to escape single quotes and new lines for safe JSON parsing. Is just this is safe content, and finally I'm going to be yielding this particular data to the client. Okay, so we are going to have, so we are going to have data and the /n/n. This is just protocol. Okay, the server sent events requires you to add this and this at the start and at the end, and this is going to be the JSON that we are going to be sending to the client. Okay, so this is going to have the type. Okay, it has the escape characters. Okay, because we are using double quotes within double quotes, but the type is going to be content, and the content itself is going to be this particular safe content. Okay, so we are emitting this thing. Similarly, we are also emitting another event type called on chat model end. Okay, so we are emitting some data. Why are we doing this? So let me actually show you why we are doing this. So in this case, I'm going to change the thread ID, and I'm going to say I'm going to make use of I'm going to force the agent to use a tool call. Okay, so that I can show you why we're doing that. So I can say when is the next SpaceX launch. Okay, so if I run this, okay, so we can see that the LLM has started to generate. So right here you can see that all these on chat model streams, the content is not going to be there. Okay, because if I come back to the end. Okay, so this is where the LLM is done generating something. So in this case, you can see that the content is going to be empty and it has completely shown that we have to call this particular tool call. Okay, so you can see that it is saying that use this particular query, use this particular tool, and then do an internet search. Okay, so this is what we are grabbing. Okay, so we are grabbing this thing so that in the UI you can see that we are showing this particular, we are showing this particular thing. Okay, so searching the web and the next SpaceX launch date. So in order to show both of these things, we need to grab this on chat model end. Okay, so sometimes the tool calls might be there, sometimes the tool calls might not be there, but we're only isolating when there might be tool calls. So that is exactly what we're doing right here. So we're checking if the tool calls are present or not. Okay, if it is not present, it's going to be an empty array. And then we are looping through it. And then we're checking if there is at least one tool call where the Tavily search is needed. So if it is not there, no problem at all. But if it is present, in that case, we will have to start showing this, searching the web, all this. Okay, so that is why we're emitting a different event. So what I'm doing, I'm just going to grab the query alone. So you can see that we're signaling the search is starting. We're again escaping. This is some parsing that we're doing. And then we are yielding a different type. Okay, so here we saw that we were yielding a type content and the content name. In this case, we are going to be yielding type search start. And then we are passing the query as well. So this is how the client can actually differentiate between what is what, right? So we might want to show a different UI or something like that. In that case, the client can easily differentiate based on this particular type. So in this case, it's going to be search start. All right. So what's the next thing? So we are also emitting this on tool end. So what is that? So if I come down here, we have this on tool start and on tool end. So it's only in the on tool end where we are having the full response of the Tavily search tool. Okay, so this is where we are seeing the entire, the 4 URLs that it pulled the data from. So this is where we are able to see everything. So this is why we don't want the on tool start, because we are not going to have this particular information at that point. So that is why we are grabbing a hold of this on tool end event. So that is why I'm taking the on tool end event, and I'm also making sure that the event name is Tavily search. Okay, so there in the future, if you want to extend it, there could be multiple tools, right? In that case, you will have to add these conditions as well. Okay, so I'm grabbing the output. So this is going to be the output. In this case, it is going to be a list, right? So the response of the Tavily search is going to be a list of 4 different items. Each item is going to have the title, it's going to have the query, etc., etc. Okay, so that is exactly what I'm going to loop through, and I'm just going to grab the URLs. Okay, because for the UI, I'm just going to show the URLs. So that is why I'm just providing the URLs. Okay, I'm converting the URLs to JSON, and finally, we are just going to be yielding it. So in this case, the type is going to be search results. Okay, earlier it was search start, and now it is going to be search results. All right, and finally, we are just going to send an end event. Okay, so this is going to be the complete server side code. So what I'm now going to do is I'm going to make sure let me just close this up. I'm going to run this file. Okay, so I can run it by saying uvcon. Okay, so uvcon is going to be, if you've worked with Node.js, we've got nodemon, right? Okay, similar to that, we've got uvcon in FastAPI, and we are going to go into this particular app.py. So that is what this thing stands for, the first part. And then the second part is going to reference this particular variable. Okay, where is it? So we are going to reference this particular variable. Okay, so this is going to be the FastAPI instance. Okay, so we're getting a reference to that. And then we're also saying -- reload, because if at all we want to make some changes, immediately we want the server to be restarted automatically. Right, so that is why we are saying reload as well. So let's now run it, and I'm going to be testing this API endpoint. So I'm going to be testing this using Swagger docs. So if you do not know what Swagger docs is, it's basically like Postman, but it is something that FastAPI provides out of the box that we can actually use to test our endpoints. Okay, make sure that everything is working fine. So to access it, I can just say docs, And this is going to give you a very nice UI about all the different endpoints that we've written. In this case, we only have this one endpoint that we've written. So chat underscore stream and then messages. So if you click on it, you can see that it automatically shows you, okay, we have to provide this particular message, which is going to be required. And we can optionally provide the checkpoint ID as well. So I can click on this, try it out. So in this case, I can say something like, what is the, let's say, current weather, okay, weather in Delhi. Okay. So if I do that, you should be able to see all the different events that are emitted. Okay, it's taking a while. Okay, great. And right here, you can see that the first event that was emitted contains the checkpoint ID. So the client can actually grab a hold of this, remember it for future requests. All right. So since this is a query that requires tool calls. So in this case, it is going to return some empty content. Okay. So in this case, it's not going to do anything on the front end. And then you can see that search has started, right? This is we on the client side, we can grab this thing and then we can show a nice UI like this one. Okay, search has started, and we can also, we also have access to the query, right? We also have access to the query. All right. So once the search is done executing, once the Tavily is done executing, we are also getting another event where we are getting all the URLs. Okay, all the 5 URLs, 4 URLs, I think. And then we can make use of that as well, and we can show it right here. Okay, so I hope that you are able to see how it's all coming together. And just one hiccup, guys, one thing that I ran into when I wanted to run this code, one thing that I ran into was that there was a certificate issue that I kept getting when, the agent wanted to run the Tavily search. Okay, so this is going to be the fix, guys. So in the README, so all that I did was I just installed certify, and then I just put this particular line in the terminal as well, and that fixed the issue for me. All right, so let's move back. So what happens next? So right after we show all the URLs, okay, then we have access to the type content again, right? So we can now, okay, get all these different keywords, okay, all these different tokens that are being generated. So it's all going to be part of the type content, right? And then we can actually show it right here very neatly. So I really hope that you are starting to see how it all comes together. So in the next part of this video, we are going to be building out the React front end. So I'm pretty excited. I'll see you there. Hello guys. So in this section, we are going to be building out our UI using React, and more specifically, we are going to be using a React framework called Next.js. And again, if you're not a front-end developer, that is completely fine. You can just pull this code, clone this repository, and then just put in the commands that I tell you to put in. Okay, so you just need to run this npm run dev, and that is going to spin up the server, and everything should work perfectly fine. Okay, but if at all you are interested in front end, okay, so this particular part is for you. If you're not interested, always skip over it. But it would still, I believe it would still help to know on a very high level how things are working on the front end. Okay, so to start off with, I'm going to be using, as I said, I'm going to be using Next.js, which is going to be a framework of React. Okay, so if I go to react.dev, you can see that, Next.js is something that React recommends as well. And this is the command that I ran. Okay, so basically open a directory and then run this particular command, and that is going to give you this boilerplate code. Okay. So once you have this, this is where everything is going to start. Okay, so this app folder is going to be present in this brand new project structure. Okay, inside of this, you would also find a page.tsx. This is going to be the file where the topmost component in your entire application is going to sit. So what I mean by that is, if I just go and, okay, so if I just, let's say I get rid of all of this and I just say something like, hello world. So if I save this and I come back to the UI, you can see that it says hello world, right? So let me actually go back. Let me undo all of the changes, and now you can see we have the earlier UI, right? So this is going to be the topmost file, and this home is going to be the topmost container that is going to be the starting point of our application. So if I scroll down to the very bottom in this return part, you should be able to see we have the header and the message area and the input bar. So what are these three things? This header is just going to be the static. Okay, it doesn't do anything actually. Okay, it's just going to be there for the aesthetics, right? And then we have the message area, and this message area is for whatever shows up in this particular window. Okay, so if it is a user, it should come on the right side. If it is not a user, it should come on the left side. So all these things are going to be taken care of by this particular component, the message area component. Okay, so we don't want to go too deep in the weeds and try to figure out what is doing what. If you want to do that, just pull the code and then you can take your own time with it. But since this is not going to be a front-end focused course, I'm going to be skipping over it quickly. So we have the header, message area, and then finally we have the input bar. Okay, so this is what we're talking about. So anytime we type something in here, we are going to be grabbing a hold of that current value, and then we're setting the current value right here. And then anytime an enter is pressed, in that case we are going to fire this particular event handler called handle submit. Okay, so this is the UI part. Let's scroll up and let me show you what we're doing right here step by step. We are maintaining the list of messages right here. How can I help you? This is something that we are hard coding right here. Okay, so we are assigning it an ID, a message ID, and then we are also having this is user property, and that is going to be false in this case, right? Because this the AI is only asking this particular message, right? So it's going to be false, and the type is going to be message. So there's going to be different types of data that is going to be populated here, right? So in some cases it could be the search query, some cases it could be the search results. In all those cases, the type is going to be different. Accordingly, we can show different UI for that. Okay, so before we move on to that, let me show you what are the other things that this object could possibly hold. So this is going to be a TypeScript interface. You can see that ID is going to be a number, which we've already seen. The content is going to be string, which we've already seen, is user, and then the type, and then is loading. Okay, so right after the request hits the server and before the LLM actually starts generating something, we are showing a typing UI, right? So if I say I am Harish, okay, so in this case you can see there's going to be a typing UI, right? So that is going to be maintained by this is loading. Okay, and then we have this search info, right? So this is going to contain stages, query, and URLs. So stages is basically like initially we could be searching the internet. Okay, searching could be a stage, and then reading could be the next stage, and then writing, right? Okay, so these are the different stages. Why are we maintaining it? I'm just maintaining it because to show the UI in a certain way. Okay, so let me show you what I mean. So I'm going to be using the same query that we've been using. So I'm going to ask when is the next SpaceX launch. Okay, so in this case, okay, so you can see that we are searching the web. That is going to be one stage, right? And then we are reading it, and then we are writing it. So it's all going to be part of this entire thing is going to be part of one particular AI message response. So that's how we can think about it. Okay, so it's all going to be part of one message. So we look at that. So, okay, so this is going to be the main method. Okay, so 99% of all the logic is going to be maintained at this one handle submit method. Okay, so whatever happens when we type something and we press enter, so this particular event is going to get triggered. So coming down, so this current message, okay, so whatever the user is currently typing, that is going to be maintained here, and then we are going to create a new message ID. Okay, we're just going to grab the maximum ID that is present in this existing list, and then we're just adding one to it. Okay, so that is all that we're doing. And the next thing is we're just grabbing the current user message, and then we're updating the state right here. Okay, so this is going to be a synchronous operation. So immediately we can just add this new item in the list of messages. So you can see that I'm Harish. If I say this thing, immediately we expect it to show up here. Okay, so that is what this thing does. And then let's look at what we're doing. Okay, so we're clearing it out because we don't want it to linger on here. Okay, we want that to be cleared, so that's why we're clearing this out. And then this is where the actual the streaming, receiving all these streamed chunks is going to happen. Okay, so inside of this try block. Okay, so the first thing that I'm doing is I'm going to create a loading. What we do is when we type something here, we can see that there's something loading, right? So essentially what we're doing is we're creating this AI response ID. Okay, we're setting the content to empty string. The user is false, so that it shows up on the left side and not on the right side. The type is again going to be messages. we're setting the is loading to true, okay, because the chunks would not have started to come yet, right? And then search info, none of these stages would have started to happen. And the next thing is we are constructing the URL, okay? So we know that this is going to be the API endpoint, right? So this is going to be localhost 8000, exactly where our server is listening to, right? So we are going to grab this particular URL and then we are going to construct this entire URL. We are passing in the user input as well. So whatever message that the user has entered, that is going to be set right here. And then we are checking if the checkpoint ID is present or not. Initially, the checkpoint ID is not going to be present. So we are going to come down. And then this is very important, guys. So we know that we are dealing with server sent events on the server side, right? So how is the client actually going to, know that, events are getting emitted? Okay, so something is being streamed. So how do I capture it? So the browser actually gives you this particular API, browser API called event source. Okay, so this is going to be very important. So we are using this to connect the server sent event endpoint using event source. Okay, so we are providing the URL right here. We are initializing it. Okay, so anytime there is any event at all being consumed or received on the client side, this particular event handler is going to get, this particular callback function is going to get triggered. Okay, so this is where most of our logic is going to be done. Okay, so in case there is an error, this particular block is going to be executed, but you can see that that is going to be the end of it. So let's look at what is the first thing that we're doing. Okay, so from this event, we are going to get whatever data that was sent from the server side. Okay, so we're extracting the data from that, we're parsing it, and then we now have the object right here. Right now we're checking what type is it. Okay, so there's a couple of different types that we're checking for. So now you can see that we have like 6 different types that we are checking for. We had the checkpoint type, we had the content type, search start type. Okay, so if it's checkpoint, we're just going to store it on the client side using this particular use effect. Okay, so that for the next follow-up question by the user, we can just attach it. Okay, so that's what we're doing right here. Okay, so we can just where is it? So if it is there, we're just going to attach it in this particular query param. So this way the server is going to know, which particular session it is, and it can continue the memory from it, right? So coming down, so this is going to be data type checkpoint, and then we have the content. So if you're dealing with the content, we are just going to, whatever data is being received, we are going to, add it to this streamed content variable. Okay, initially it's going to be an empty string. We're just adding. So, if it says, hi Harish, how can I assist you today? So initially the content is going to be hi, and then, okay, it's going to append it. Okay, and then it's going to add it to this particular streamed content. And then as and when it is coming, we are also updating the state right here. Okay, so that we can actually reflect it in the UI. And then let's move on to the next thing. So we have data type search start, right? So along with this, okay, let's search for the search start in this thing. So you can see that along with the search start, we are going to provide the query as well, right? So whatever the internet search query, so we are going to grab a hold of the query. We are going to add it in the state as well. Okay, so the URL is still going to be an empty string. And then as usual, we are going to update the AI message with the search info. The same thing for the search results as well. So we're looking at, the data URLs, okay, and then we are going to update the URLs right here. So we are going to get the URLs from here, okay. So if I search for the search results, you should be able to see that we are sending the URLs, right? So we're grabbing a hold of that, and then we are updating the state again. So the minute we update the message there, we are going to show it in the UI. And then finally, we have the end event. So if we get this end event, we are just going to close the event source. Okay, so we don't have to keep it open more than we absolutely have to, right? So we are going to immediately close it. And that is it, guys. So if you are interested in, what we are putting inside of the components, it's just going to be some, Tailwind CSS. It's just going to be some, animation. We are using some animation, etc., etc. And even if you're not a front-end developer, guys, and even if you don't, understand this code, it's going to be pretty simple. Just copy paste it to ChatGPT or Claude, ask it to walk you through it, and I'm sure it would start making sense. So that is it for the front-end code, guys. So the next part is going to be, we are going to be deploying our server code. We are going to be deploying our AI agent. So I'll see you in the next section. Hello guys, I'm excited. Welcome to the last part of this course. we are going to be deploying our application. Okay, so far we built the server side code, we built the graph, we've tested it locally, but eventually we will have to deploy to production, and that is exactly what we're going to see. There's quite a lot of different ways to do it. My favorite way is to do it with Docker. Okay, so this is going to be the backend code. I haven't touched it at all since the last time we saw it. So the only two things that I've added to this repo are this particular Docker file and this Docker ignore. Okay, so this Docker file is going to have all the instructions that is necessary to put the project together in a different server, okay, in a public server. So I expect you to know some amount of Docker already. So here is what I'm doing. I'm basically going ahead and pulling a Python image, and then we are setting this work directory to be app. So inside of the Docker container, we are telling, okay, create an app folder, and then we are going to copy this requirements.txt, okay, into that particular app folder, and then we're also installing this in requirements.txt. Okay, and then we are going to copy the rest of the application code, including everything, right? Okay, so we don't want this IPYNB, so we can actually go ahead and delete it. I'm just going to keep it around in case we might need it for something. But actually, when you're running, when you're building this image, okay, we can actually go ahead and delete it as well. So we're essentially copying the rest of the things and then moving it inside of the app directory. And also, we don't want to move the contents of the environment file as well. So that is exactly why we have this Docker ignore file as well, where we're going to put in all the different files that we want Docker to ignore, right? So we are going to copy the application code, and then finally we are going to expose the port 8000. And then this is going to be the command to run the application. Okay, so these are some things that you would recognize, right? Uvicon app, right? So this is what is going to spin up our container. All right. So once we have the Docker file and the Docker ignore setup done, so now it is time for us to start building our image. Right, so once we build out our Docker image, we can then use a cloud provider. So I'm going to be using Render. Okay, so you can use DigitalOcean if you want. I'm going with Render because they offer a free tier, and it does have some downtimes. Like if you don't use the server, it is going to take some time to spin up again. So there are some drawbacks, but since we're just learning, this is going to be ideal for us. And then for the different steps that we have to do, like building the Docker image, testing it locally, right? Okay, pushing to Docker Hub. You can see that I'm actually using my own API keys right here. So I want this to be extremely easy for you as a viewer to follow along. So I'm going to be removing all these API keys as soon as I upload the video. But yeah, this should make it extremely easy for you to follow along. Okay, so the first step that we have to do, okay, so you can see that this guide contains exact commands with your credentials for building, testing, and deploying your Perplexity app. So that's what I'm calling it. So personalized Docker and Render deployment guide. So step one is going to be, we have to build the Docker image. And if you're wondering why we have different commands for Apple Silicon and the rest of it, and that is because Apple Silicon has a different processor, and if we build the image in a different processor, we cannot actually use Render because Render only accepts this AMD 64 processor. So that is why we are using this, and then we are making it standard. Okay, so let me actually copy this thing. This is going to be the first command. Okay, and then I'm going to copy this entire thing and then put it right here, and that is going to go ahead and start building my Docker image. So this might take some time. And if at all you're using Windows or Linux or Intel Macs, in that case just say docker build -t perplexity latest and a dot here as well. Okay, so why do we have this dot? We're just saying that it is in this particular root directory where we have this Docker file. So we're basically just giving it the location to our Docker file. All right, so while this is taking some time, let's go ahead and let's move on to step 2. So whatever image that we built right here, we are going to run it. Okay, so we are going to run it as a container, and we are going to test it. We have to say docker run. So this is how we run an image. Okay, so this is how we run a container, and we are saying -d. This is a detached mode. Okay, so we don't want to worry about all the logs. Detached mode, and then we have this -p. So what this means is we are specifying the ports. So the container itself is going to have ports. Okay, so that is what we are saying, that okay, in the container use the 8000 port, and once the container is running, if you want to tap into, if you want to access that port inside of the container, use the local host 8000. So that is what we are saying right here, 8000. So this 8000 is going to be the port of the container. This 8000 is going to be the port of the host machine. All right. And then we are going to set the OpenAI API key. We are going to set the Tably API key. And then we are going to give this container a name called Perplexity container. Okay. And then the image that we are going to be using is Perplexity latest. Okay. So the same thing that we mentioned right here. Okay. So let's actually go ahead and copy this and let me see if it is done. Okay, great. So you can see that the image has been built. So now let's go ahead and run this image. Okay, great. So now you can see it has given the container name. So if I actually go back to my Docker desktop, so right here you can see that we have the container running right here, right? So we have Perplexity latest, which is currently running on port 8000, right? So I can just come back to Chrome and I can go to localhost 8000. Okay, so now you can see that if I actually go to docs, you can see that we are actually able to access the endpoint and everything, right? So this is actually amazing, right? So you can see that we don't actually have any server running right here. So we're directly listening to this particular server. It is actually the container that is running our entire Python server, including all the LangGraph files as well, right? So now we know that the container is working fine. Now let's go ahead and push it. So let's actually look at what is the next step right here. Okay, so the next step is basically to push to Docker Hub. So now let's actually go ahead and we can also stop this particular container. Okay, we don't want it to be running because we now want to push it. Okay, so it's been stopped. And then we can also, do this particular command as well. So now let's go ahead and log in, okay, to Docker Hub so that we can actually push it to Docker Hub. So once we have it available in the repo in the Docker Hub, we can actually, go inside of a public server and then pull it, and then we can build the same image there as well. And then we can have our application be available globally, right? So I'm going to go ahead and say Docker login. Okay, so I can say Docker login. Authenticating with existing credentials, username Harish Neil. Okay, so it's because I've already logged in, but if you have not logged in, it's going to, you can just provide your credentials and it's going to log you in. Okay, so what is the next thing? So the next thing is we have to tag our image with your Docker Hub username. Okay, so this is going to be the command Docker tag Perplexity latest. Okay, and then this is how we can actually do it. So let me copy it, put it over here. And now let's go ahead and push the image to Docker Hub. So we say Docker push, and this is going to be the username of my, Docker Hub. So if I go here to Docker Hub, okay, so you can see that this is going to be my username, right? So Harish Neil is going to be my username. So that is exactly what it is showing right here. For you, it is going to be something else. And as you know, this is going to be the name of our image, right? So this is going to be the tag as well. So let's copy this entire thing and then let's go ahead and push it to Docker Hub. So you can see that it's preparing, waiting. So now it's actually going to be publicly available for, the world, right? So let's actually wait for a little bit. Okay, great. So it is done pushing. So if I actually go to Docker Hub right here, and great, you can see that it has been pushed less than a minute ago, right? So this is what we want. And now this is actually available publicly. So the next step is going to be very simple. Okay, so let's actually go back to our artifact. So we are going to be deploying on render, right? So I can go to my dashboard. Okay, so I can click on add new and I can click on web service. Okay, so right here, I can click on existing image. So in here, I can actually provide the Docker image URL. And for you, the username is going to be different. For me, this is going to be the image URL. So let me copy this and put it over here. Okay, great. So you can see that there is a tick mark right here. So I can now go ahead and click on connect, and then you can create a project if you want. I'm not going to do it. I am going to go for the free version right here. I can leave this region as it is. So coming down, this is where we have to provide our environment variables. So we have to provide the OpenAI API key, and we have to provide the tably as well. So I'm just going to quickly go ahead and copy that. So I'm just going to copy this, put it over here. This is going to be the OpenAI's. This is going to be the tably's. All right. And that is it. So now all that I have to do is deploy this. So right now what's happening is, render is automatically pulling the image from Docker Hub because it's now been made publicly available. It's pulling it, and you can see that it is actually, running it. It's building it in its own server, and it's going to make our application available to the world. So you can see that the service is now live, and now you can see that up here it provides me the new API endpoint. I can just copy this and I can actually go ahead and run this, and you should be able to see that we can actually access the Swagger docs of our deployed application, okay, in this particular endpoint. Okay, so now what I can do is I can just copy this endpoint, come back to my client side code. Okay, so right now it is actually pointed to our local host, right? So instead of this, I can actually replace this. Let's remove this docs. Okay, let's save this file, and let's actually now go ahead and see if everything is working fine. So in this case, I'm going to say, I'm Harish, how are you? Okay, so now you can see that it is actually working, guys. So our application is successfully deployed on render. So if I actually inspect it and show it to you in the networks tab, you should be able to see calls going to render right now. So I can say, what is the weather in SF? So in this case, you can see that all the calls are actually going to Perplexity, right? Okay, so it's going to onrender.com, right? So perfect. So everything is working as expected. So if you want to go ahead, deploy the front-end code as well, that is pretty easy. There's a bunch of tutorials out there on how you can deploy a Next.js application on Vercel. And if at all you want to steal the code, I don't mind at all. Please go ahead, pull the code, clone it, and then change the UI a little bit, and then go ahead and put it in your list of portfolio projects. So I don't mind absolutely at all. Okay, so and that is it, guys. I hope you learned a lot, and I'll see you in the next video.